Hey guys, this is Unit 2, and this is our fourth video, 2-4. We're going to talk about chemical reactions. The first thing I want to point out is during this video, I may abbreviate chemical reaction as RXN. So it's simply just a shorthand way of writing out chemical reaction. And the next thing we need to talk about is the idea that a chemical reaction is the result of a chemical change, or another way of saying it is, it causes a chemical change. So just like before when we were talking about physical changes, okay, now we have a different option. Physical changes didn't actually change the identity or the composition of the substance, but a chemical change does. In fact, it is going to break or form bonds, and in that process it will change the composition of the substance. So you will produce a brand new substance from the original substance. Now we have a special name for this. A reactant is the original substance. So the reactant's the original, and then the new substance would be the product. So products are the new substance, reactants is the original. Another way of defining it is a reactant is a substance that is used up by the reaction, whereas a product is something that is made by the reaction. Little generic setup, if you think of it this way, if we have substance A, we combine it with substance B, and we produce substance C plus substance D. Okay, the arrow is pointing away from A and B, so these would be the reactants, and the arrow is pointing towards C and D, so these would be the products. Okay, another idea that we need to understand in terms of chemical reactions is this concept of the law of conservation of matter. What the law of conservation of matter states is that matter can neither be created nor destroyed. Okay, and this is by normal chemical means. So meaning normal chemical reactions. There's technically some nuclear reactions that we could do that would like shatter atoms and things like that. So you might get into ideas that way, but by normal chemical means you cannot create or destroy matter. Okay, and then in terms of what does this mean when we're looking at a chemical reaction? Well, it means that the mass of the reactants must equal the mass of the products. So let's go back to our example from the previous slide. A plus B produces C plus D. Okay, let's say that A is 3 grams. We know that we took 3 grams of A, we combine it with 2 grams of B. Okay, and let's say that we measure out C. Let's say C is a solid. Okay, and we're able to measure out that 4 grams of this were produced. But let's say that D is simply just a gas, like smoke. Okay, hard to collect, really hard to put on a scale and weigh it, right, or determine its mass. But if we know the law of conservation of matter, we know that this side, if we add it together, so 3 grams plus 2 grams gives us 5 grams, we know that this 5 grams has to be represented in the products as well. So if we take 5 grams from over here, right, subtract our 4 grams, okay, that's going to leave us with 1 gram left over, which is how much of D we had. So we couldn't measure the smoke, we didn't collect it, we didn't put it on the scale, but we could in fact use the law of conservation of matter to determine it. The next idea about chemical reactions is the idea that energy changes over the course of a reaction, meaning that chemical reactions involve a change in the energy of the substances involved. So there's really 2 options. You can either gain energy or you can lose energy. That's how it works. Energy is either absorbed or it's released. So if energy is absorbed, we call that an endothermic reaction. The way I remember this is that the EN in front of this stands for enter. So energy is entering the reaction, it's absorbed, and what this means is the reaction is going to take in energy from the surrounding environment, so they typically feel cold. Now the opposite would be to release energy. If you're releasing energy, that means it's going to feel warm because you're going to feel the energy being released and entering your hand. And the way I remember this is the EX here stands for exit. So energy is exiting the reaction. Now everything we're talking about in terms of chemical reactions is really just a way of describing the chemical properties of a substance, meaning that different substances react in different ways. And when we determine how a substance is going to react, we call that a chemical property. It's a quality of a substance that can only be observed through chemical reactions. So for example, if we take a piece of paper and we heat it up until finally it bursts into flames, that's the flash point, basically the temperature at which it will combust. So that's a chemical property. And the reason why I would call it a chemical property and not a physical property is when we're done, okay, the substance is no longer whatever it was. So for instance, paper, right, if we burn it, so here the arrow stands for burning it, that's the reaction that's occurring, and we're left with ash, right? Ash and smoke. Ash and smoke is no longer paper. So it's gone through a chemical reaction. We have completely different substances when we're done. We call that a chemical property. Let's talk about a generic reaction setup. This is my generic reaction setup up here. I have my reactants. I add something called the energy of activation. The only thing you need to know about that right now is that it's the cost. It's the initial energy you have to put in to get a reaction to happen. And then we produce products plus or minus energy. This plus or minus, we're really just talking about exo, endo. So if you have plus energy, that means energy is being given off. That would be exothermic, right? So it's going to feel warm. And if it were negative energy, that means that energy is being absorbed. So therefore it's endo. Okay, and it's going to feel cold. There's more information that we can add to this reaction setup. For instance, we can add subscripts. We've added subscripts in the past. Here's one actually that there's a little typo here. So this 2 should be down here as a subscript to make it look like water. But in this case, we're using the subscripts to show the phase of each substance. So S in this case is going to stand for solid. L is going to stand for liquid. And G is going to stand for gas. There is one more subscript that you may see, and it's AQ. AQ stands for aqueous. And what aqueous is basically a solution in which water is the solvent. Or another way of saying it is, this means that whatever the substance that we're describing as aqueous, whatever it is, it's dissolved in water. So AQ, aqueous, think of it as like aqua. Okay. So here's an example. We have silver. The S tells us that it's solid, and here we have water. The L tells us it's liquid. The other thing that we can do in a reaction setup is we can use coefficients. Coefficients will show us how many copies of each substance are part of the reaction. Well, what is a coefficient? A coefficient is a number in front of a substance. Let me give an example. So if we go back to the whole A plus B, etc. Okay, let's say that we have 3A plus 2B produces, let's say 3C and 1D. Notice I did not put a 1 here. That's because just by writing D, we're saying that there's at least 1. So we don't actually have to put a 1 in front of it. Okay, it's the only coefficient that we do not have to write. But these numbers over here, the 3, the 2, and the 3, these are other coefficients. And what they're really telling us is that there are actually 3 A's that are needed to participate in this reaction. So I could write it another way. I could say A plus A plus A, okay, and then combine it with 2 B's. So B plus B produces 3 C's. So C plus C plus C plus 1D. Okay, so I could write it out that way, but that's a long and kind of tedious way of doing things, right? By using coefficients, we're able to condense this. It makes it faster to write, it makes it less work, and we're still communicating the same information. Now the last topic I want to talk about are the signs of a chemical reaction. So in other words, what observations can you make that suggest a chemical change or chemical reaction is occurring? Well, we said that all chemical reactions cause a change in energy. So the first 2 things that we can basically observe is, for instance, if there's a release of energy, what would that be? Yeah, if it's releasing, that means energy is exiting, so therefore that just means that it's an exothermic reaction. Okay, it's hot. The opposite, the absorption of energy, that means that energy is entering and it's going to feel cold. That would be an endothermic reaction. So the first 2 signs are really just saying, hey, there's going to be a change in energy. If energy is released, it's exo. If energy is absorbed, it's endo. And we know that whenever energy changes like this, it's a chemical reaction. Number 3, production of light, production of sound. Example of this, light, would be something like a glow stick. Any sort of chemical reaction that causes crackling, popping, That would be an example of sound. Number 4, production of a gas or bubbles. If we mix two liquids and all of a sudden it starts bubbling and releasing hydrogen gas or carbon dioxide or something like that, good sign that you've had a chemical change because you're producing a substance that wasn't there before, a gas or bubbles. 5th option is it could change color. Maybe you have a clear liquid, you add some powder to it, and maybe the powder is like white, but when the white powder hits the clear liquid, all of a sudden it turns, say, red, something like that. So it would change in color. And then the final option is you can have the formation of a precipitate. This one's kind of weird. Think of it as I take two clear liquids, I mix them together, and then a solid forms, basically little white specks or little white flecks, or it could be, it doesn't have to be white at all. It could be like brown or black or any other color. But the point is you have little solids that form in the liquids. These are what we call precipitates. They are insoluble solids. By insoluble, I mean that no matter what you do, you shake it, you stir it, you cannot get them to redissolve into the solution. They simply just float at the top or fall to the bottom, but they are little solids that form as a result of the chemical reaction. Okay, so that's 2-4. Hopefully you understand a little bit more about chemical reactions. Make sure you complete your whisk, make sure that you complete your guided notes, and we'll see you tomorrow.